Hey everybody, welcome back. Gary Simmons here for the Game Institute with lesson 56 in the Dead Earth game development series. In the last lesson, we completed our power generator, and we also wrote a material controller class and an interactive generic switch class, which is going to be a lot of use going forward. In this lesson, we're going to create our computer system construct. This is the second puzzle in the Creeper game that will allow the user to deactivate lockdown mode. Unlike the power generator, however, and the access code puzzle that we're going to create in the next lesson, our computer system construct isn't an interactive item. It doesn't use our interactive item framework. It isn't an object that will be sensitive to the character controller casting a ray through its collider. Instead, this is going to be an area trigger, so we don't need to be looking at the screen at all times. We just have to be in the general vicinity of the computer screen, and pressing the use key will start to deactivate lockdown if it's not already deactivated. So the first thing we're going to need is to create the graphical elements that we need to create this effect. Now, if we select our computer monitor in the scene, you'll notice that the blue screen is part of the mesh, so we can't just individually select it and change its material. So what we're going to do instead, as I showed a few lessons ago, is we're going to create a cube, and then we're going to assign that a black material in the case when the computer is off, and another material when it's on, and we're going to push that cube into the TV screen so that it covers up the blue screen. Now, we have to be pretty precise with this, because if I zoom in on it, you can see the monitor screen does have a curvature on it. So if we push the cube in too far, we're going to see in the center of one of the cube's faces the blue screen poking through. But if we don't push it through enough, then it's going to look fake, and it's going to look obvious that we have a cube that's just sticking out of the TV. So we're going to start by adding a new cube game object to the scene. So let's go to the game object menu, the 3D object sub menu, and choose to create a new cube. Okay, let's drag the cube nearer to us. There we go. And what I'll do is I will roughly resize it for now. So I'll put the scale on the X down to 0.6, the Y down to 0.4, and the Z down to 0.4 also. And then I'll rotate it around, move it down here, move it closer to the TV screen, move it up, something like that. Okay, and I need to rotate that around. Something like that. That's very rough. So what I'm going to do now is I'm going to pause the video. I'm going to put in the exact numbers into the transform of this game object, and then you can pause the video when I come back and copy over the numbers exactly if you want to. Okay, and I'm back. So if you pause the video now, I will zoom in on the transform so that you can copy over the position, the rotation, and the scale of this object exactly. Next, we need to remove the box collider. This object does not need to be collidable, and I'm going to rename this cube in the hierarchy, and I'm going to call it computer screen off. Now we need to create a nice black material for it. So I'm going to drill down into my materials folder, which is underneath the Dead Earth folder. We currently have two materials in there, our blood particles material and our keypad material. So I'm going to create a brand new material, and I'm going to call this the same name as the game object, computer screen off. Like so. I'm then going to select the cube and drag that new material into element 0 in the mesh renderer's material list. Nothing's changed yet because that material we just created has been assigned that default grey colour. So let's now select the material and via its inspector set its diffuse colour all the way down to 0, and we'll also leave the smoothness up a little bit so we get a little bit of reflections when we put a reflection probe in there, and we don't need any emission either. So there you go, there is our computer screen in its off position done. So next up we need to create another cube that's exactly the same size that has a different material on it that we can show when the computer screen is active, because our power generator is going to have this computer screen off game object that we just created in its object deactivators list, and it's going to have the new cube that we're just about to create in the object activators list. So when we turn on the generator, this thing is going to get turned off and the new cube we're about to create is going to be turned on. So let's duplicate this cube, and we'll call this one computer screen on. And in my materials folder, I'm going to create a new material. And as you've probably guessed, this is going to be called computer screen on. I'm going to turn off the computer screen off cube, so just the computer screen on cube is there. And I'm going to drag the computer screen on material onto the computer screen on game object. Let's now set up the computer screen on material. We want this to be purely emissive, so I'm going to set the albedo color down to black. And I'll move up the smoothness a little bit so we get some reflections later on when we put a reflection probe into the scene. And then I'm going to drill down into my textures folder, and you'll see that we have this texture here called computer lockdown activated, which is the starting state of this computer system. And I'm going to set this as the emissive texture for our material so that even if no lights are shining on the computer monitor, it will still glow emissive red and white. So now we know the texture we're going to use. Let's go back up and select our material, and let's enable emission in the computer screen on material. This will then expose a texture slot where we can drag and drop that emissive texture. It's all flipped around the wrong way at the moment, so rather than mess around with the position of the game object, I'm just going to change the tiling of this material to -1 on the X and -1 on the Y. And there you go, that is our basic background done for when the computer screen is on. What we need to do now is we need to create a world space UI canvas, and we're going to resize that canvas so that it overlays exactly the computer screen, and we're going to use that UI canvas to display some text along the bottom of the screen, and also to implement that slider bar that is going to go from 0 to 100% while the user is holding the use button. So let's go to the game object menu, and from the UI submenu, let's choose to create a new UI canvas. We want this to be a world space canvas, so from the canvas component, we will change the render mode from screen space overlay to world space. Then I'm going to take my canvas game object and make it a child of the computer screen on object. And I'm going to rename the game object computer screen UI. Let's zoom out a little bit so we can see where this canvas is at the moment. Yep, it's nowhere near our computer screen, so we're going to have to resize the hell out of this to get it down and overlaying our computer monitor. So if memory serves, I need to set the position Y to about 0.59 and position Z at 0. I also want to change the width and the height to be 100 and 75 respectively. I want the rotation to be 90, 0, and 0 for XYZ respectively. And now what we need to do is really scale this thing down. So let's scale it down to something really small like 0.1 and see where that leaves us. Okay. Yeah, we're there, aren't we? Almost. It's just still way too big. So I'm going to pause the video while I figure out the right scale here. And then when you come back, you can pause the video and copy over my scale values. So I've scaled X to 0.012622024, although I'm sure that many decimal places aren't necessary. And you can see that pretty much lines up with the width of the monitor. And I need to then find the scale for the Y, which I'm going to paste in now because I know what it is. And I used a scale of 0.014482. So that is the final size of our canvas, all nicely rotated to line up with our monitor screen, and also the right size. It doesn't need to fit exactly because our text elements are going to be centered towards the center of the canvas, so that doesn't matter too much. So next we're going to create the UI element that displays the text along the bottom of the computer screen. So let's go to the game object menu, and from the UI submenu choose to create text. Let's center that text to begin with. Let's set its color to white. Yeah, this is going to be quite blurry because we've really scaled down the size of the canvas, but we'll see what we can do about that. So I'll say hold use button to deactivate, like so, and we'll open that up a little bit like so. And then what I need to do is turn up sort of the font size a bit, and then I'll see what happens if I scale this thing down a little bit as well. Yeah, I think that's going to get us sort of nicer, crisper text like so. Probably be bold as well. Doesn't all fit on the screen, does it? So I'm going to have to, because I'm scaling it, the UI is behaving a little bit weird. Let's scale that down a little bit more. Okay, how does that look? Okay, so I'm now going to rename that game object, and I'm going to call it hint text. Okay, so if you want to copy my settings exactly, pause the video now. I'll zoom in on the inspector so you can copy over all of the values. Okay, so the next thing we're going to do is create the slider bar. That's the second and last UI element we need to create. So once again, we'll select our canvas game object, and from the game object menu and the UI submenu, we'll choose to create a slider. Dun dun dun, there it is. Pretty cool stuff. So all we really need to do is just resize this thing to roughly the size that we want it, and we'll get rid of that button in a minute as well. Okay, let's go with something like that for now. And you can see that if you have the slider selected, you can preview what it's going to look like with the value slider. And it's this value property that we're going to animate from our computer script to make it go from left to right as the user is holding down the use button. The slider UI element itself is a sub-hierarchy, and we can configure the various elements of the slider by drilling down into its children. So let's work on its first child first, which is the background color, which is currently set to white. And it's also using this sprite here to make both ends curve round. Now I don't want that, so I'm going to set the source image to none. You can see I now have just a straight blocky effect. And I'm going to set the background color to red, which is the same color as our computer screen. I'm also going to select the handle slide area. As you can see, this is the actual button. So let's disable that completely. So all we have now is a background and a fill area that is going to be overlaid on top of the background and will increase in size as we increase the value of the slider. And if you want to see what that looks like, let me just select the slider and let's move up the value slider and see how that affects the UI element. So we're almost there, but our fill area is still using that curvature. So let's adjust the fill area now by selecting the fill area object, opening it up and selecting its child called fill. As you can see, this too is using a source image to give it that curved effect on either end. So let's get rid of that. Now if we select our slider value again, you can see we have something extremely similar to what we want. Notice, however, that our slider is acting kind of weird at the moment. When we put it down to 0, the bar doesn't disappear completely, and when we put it up to 1, it doesn't go all the way to the end of the area that we've designated for it. And that's because there's some crazy anchor positioning going on the child objects that I think is there by default to make room for the handle, so that the size of the handle that you would use if you were dragging it manually as a UI element doesn't interfere with the range of the slider. It's pretty easy to fix. All we have to do is drill down into those child objects and make sure that all of their anchors and all of their sizes match the whole area that we want to use. So you can see that the background element is set up correctly. It's the full width of the region that we've allocated for it, and its anchors are also in the top left, top right, bottom left, bottom right. So let's do the same for the fill area now. As you can see, this isn't the case. This thing's been kind of messed around a little bit like so. Let's open that up. Its anchors are in the right place, but the actual fill underneath you can see has been made bigger. So we need to drag that in now so that it lines up with its parent anchors. And I think now that should be right. If I select all the objects, you can see the anchors are in the right place on every object, see? So we shouldn't have any weird offsets. And if I turn that down, it should go all the way down. And if I turn that up, it should go all the way up. So I think probably the only thing that's wrong with it now is the whole thing could probably be a little bit thinner. Maybe move it up a little bit like so. So the next thing we need to add to this construct is some spotlights. When the computer is in this mode with the red screen, we want a red spotlight coming out of the screen and lighting up these walls opposite it, so it looks like it's the monitor screen itself emitting light. So I'm going to select the computer screen on game object. Now this is the parent game object, not the computer screen UI. We don't want the light to be a child of our UI canvas. And I'm going to right click on the computer screen game object and choose to create a new light. I want to create a spotlight, and I'm going to rotate it down its X to something like, I don't know, about -90-ish, something like that. Let me have a look what that looks like. Doesn't look too bad, but I think we need to open it up a little bit. We'll increase the range to about 25. We'll set the color to just bright red, the same as our computer screen. We'll also set this to be a shadow caster, and that'll look really nice. And then I'm going to really open up the spot angle from 30 degrees to about 130 degrees. Yeah, that looks good. And as you can see, it really does look like that light is emanating from our computer monitor screen. So let's rename that spotlight and call it red spotlight. Now the reason I'm doing that is because when the computer system is first activated, this is the state it will be in. Its material will have this red texture, and we want this red spotlight activated so it looks like the light is coming from the screen. However, when we deactivate lockdown, the texture used by our computer screen on game object is going to change to this. Let me select the object and just temporarily change the emissive texture of our computer screen on material to the blue texture that will be used when we deactivate lockdown. So at this point, we're also going to want to turn off the red light and enable a blue light, right? Because it looks weird with red light coming from a blue screen. So the best way to do that is to duplicate our red spotlight. Let's turn off the original red spotlight, and I'm going to rename this blue spotlight. And then we're going to set the color to a nice blue. It's probably a bit too rich, a bit more white in it, something like that. Okay, that looks good to me. It's up to you whether you have shadows on or off. In the original Creeper, I didn't use shadows, so it looked like that, but there is something quite nice about using shadows. And the other thing that's nice about it is that if you do use shadows, then this wall will occlude the light. And what was happening in the original Creeper, which you may have noticed, was that when you turned the computer screen on, even when you were stood here, these walls here and the floor were being lit up by the red light because the wall wasn't occluding the light. Okay, so let's now put this back to its default state, which is with the blue light disabled, the red light enabled, and with the computer screen on material using the red emissive texture and not the blue one. Okay, so next up I'm going to select the computer screen on object, and I want to add a collider to this, more specifically a trigger. And I want this to be quite big because it's on this game object we're going to have the trigger and a script that intercepts when our player enters this trigger area and when it exits the trigger area. And when it's in the trigger area and the user is pressing the use key, that's when this whole activation animation is going to happen. So with our computer screen on game object selected, let's choose to add a component and let's add a box collider. It's obviously way too small at the moment, so let's move the Y up to about 1.6. Let's adjust the Y to about 3.5 and let's make this quite tall, something like that. Okay, so when we come in, we can't really get in front of the computer without standing in this trigger. We don't want to be too big so that we're over here activating it, but we also don't want to make them get too close to the monitor screen. So I think that's probably about the right size. Let's have a look at it from the top. Yeah, maybe we could make it come out a little wider maybe so that we don't have to be stood right in front of it. So let's adjust the X size of this collider a little bit, something like that maybe. Yeah, so we'd be able to activate it from kind of this angle. I think that looks about right. Okay, so next up, I want to make sure that this box collider is a trigger. And I don't want to assign it to the interactive layer. This is not an object using our interactive item framework, okay? So we can leave it on the default layer. All that's left to do now is write a script that goes on this parent game object that will flip the textures at the right time, that will turn on and off the red and blue spotlights, and will send messages to the UI to alter that slider bar when it detects that the player is inside its trigger and is holding down the use button. So let's go down into our scripts folder, into our interactive items folder, and I'm going to create a new C# script. I'm not going to start its name with the word interactive, because that might mislead us into thinking that this is a script that uses our interactive item framework. So I'm just going to call this lockdown trigger, like so. And then with our computer screen on game object selected, I'm going to drag my lockdown trigger onto it, and then I'm going to open it up in MonoDevelop. And I'll move the curly brace down onto the second line because we're not savages, and for now I would delete the start and update functions and we will add them as and when we need them. So first things first, this script is going to need to talk to those UI elements, and in order to have access to the UI classes in Unity, we have to say using unityengine.ui. Next we'll move on to the inspector assigned variables. We're going to need some serialized variables so that we can hook up the references to those two spotlights we put in the scene and also the UI elements. The first serialized variable is going to be a protected float called download time. This is where we get to set via the inspector how long we wish the lockdown procedure to take, and by default I've set this to 10 seconds. Next up, we're going to need a reference to that slider UI element. So you can see I declare a protected variable of type slider. It's serialized so we can hook up that reference via the inspector, and I've called this download bar. And of course the reason why we need access to this slider object is so that we can repeatedly in our update function update the current progress and send that value into the slider. We also have that line of text on our world space canvas which currently says hold use to deactivate lockdown. But of course we're going to want to change that text so that when we've deactivated lockdown it says something like deactivation successful. So that's why I've also declared a protected variable of type text so that we can talk to that UI element. And once again, when we go back to the editor, we'll make that assignment and drag a reference over to that UI element. Next up, we're going to need to change the texture of our computer screen from the red lockdown screen to the blue deactivated lockdown screen. So I'm going to use a material controller for that. Why not? It does all of the work for us. As long as we assign the material to our material controller in its default state, that's with the red texture, then when we deactivate lockdown, we can just activate the material controller and that will swap the red texture for the blue texture. And then if lockdown is reactivated, such as when we turn off the generator again, we can just call the material controller's activate function again, but this time passing false as the parameter, telling it we would like to deactivate the material controller and swap the blue texture back for the original red texture. Next up, we're going to need references for two game objects to the locked light, that's the red one, and the unlocked light, which is the blue one. Let's now move on to the private variables. We'll need access to an application manager so that we can get states and check states in the game state dictionary. We might also need to talk to the game scene manager. I'm not sure yet, so I will declare a member of this type anyway, and if we don't need it, I can always come back at the end and delete it. And I'm also going to declare a private boolean called inTrigger, which is set to false by default. When our character enters the trigger that's on this game object, we're going to set this inTrigger boolean to true, and when we exit the trigger, we're going to set it to false. That way, in our update function, we can check this boolean and we always know whether the player is currently inside this trigger or not. And of course, it's only if the player is in the trigger that we're going to respond to the use button being pressed. We're also going to need to keep track of the download progress. Of course, we'll set this to 0 by default, but when the download progress reaches the download time, that's when we know we've deactivated lockdown. We're also going to want to play a deactivation sound, so all I'm going to do here is just add an audio source to this game object, and then via our code we'll do get component to get a reference to that audio source, and that way we can just set that audio source up manually in the editor. We can assign it to the scene audio mixer group, and we can also assign the sound that it needs to play, which is a sound in our project I think called computer download. But we'll set this to null by default, and we will set this up in the onEnable function, which I'll talk about in a minute. I'm also going to declare a private boolean called download complete. It's basically set to true once we've deactivated lockdown and the computer is now in an unlocked state. Okay, so that's all the variables declared. Let's now move on to the methods. And the first function I want to cover is the onEnable function, and that's where we're going to initialize this object. We're not going to do it in the start function, because the start function of a mono behavior is only ever called once, irrespective of how many times the object is enabled and disabled, whereas our computer system can be repeatedly turned on and off if we turn the power generator on and off. So onEnable gets called every time the computer is reactivated, and we need that because we know that our power generator, when we shut it down, is also going to reset the lockdown state, and therefore in the onEnable function of this class, when this object is activated, the state might have changed, and the onEnable function can check the game state dictionary and determine what texture should be shown and which lights should be enabled. So onEnable is another one of Unity's magic functions. It's called by the engine when this game object is activated, and the first thing we'll do is we'll grab a reference to the application manager in the scene, and we'll also grab a reference to the audio source component that should be on this game object. We haven't added that yet, but we'll do that when we go back to the editor. And as we've just re-enabled this object, we'll also set the download progress to 0. We are either in a lockdown state, in which case download progress has to be reset back to 0 again, or the object is no longer under lockdown, in which case it doesn't matter what download progress is, it's not being used anymore, the slider bar isn't being displayed anymore, so it's safe to reset this back to 0 in either case. Remember, just because our power generator, as one of its deactivation states, has decided to reset lockdown, that doesn't necessarily need to be the case with this script. So if we go back to our power generator and decide that we don't wish it to reactivate lockdown when we turn it off, then this object can still be deactivated and reactivated via the power generator, but without the lockdown status being reset. So this script has to work both ways. Okay, so the next thing we'll do is we'll call our material controller's onStart function. If this is the first time this object has been enabled, that means the material controller will make a backup of its material settings. We don't have to worry about the fact that this object may have been enabled multiple times, because the onStart function of the material controller will ignore any requests to restart it. In other words, only the first time we call onStart for a material controller will that function do anything. So next up, we need to figure out how we need to configure this object. Are we under lockdown, or has lockdown been deactivated? So we'll first of all get a reference to the application manager so that we can call its getGameState function and inquire about the lockdown state. And we store the value of the lockdown state in this local variable called lockdown. So let's first of all check if lockdown is true, and we are in a locked down state. So we'll see if that value we just got back from the game state dictionary equals true, then we are under lockdown, in which case we will call our material controller's activate function, but we will pass in false, instructing the material that it needs to reset its properties back to how they were at level startup. In our case, that means the red computer screen, the one that says we are under lockdown. We'll also need to deactivate the unlocked light. That's the blue one that should be activated when the blue screen is activated. But of course we do wish to activate the locked light, that's the red one, and that will match the red texture which our material is set up to use when it's in its deactivated state. Finally, we will make sure that download complete is set to false. In other words, this puzzle has not been solved yet. However, in the case where lockdown equals false, then we have deactivated lockdown, in which case we will call our material controller's activate function, but this time passing true, causing the red texture of that material to be swapped for the blue one. We'll also activate the unlocked light, that's the blue one, and we'll turn off the locked light, which is the red one, and we'll set download complete to true. Finally, at the bottom of this function, we're going to call a helper function that we haven't written yet, called reset sound and UI. You'll see in a few moments that this is a function that just sends all of the values to their UI elements so that things such as the hint text and the slider bars are set to their correct values. Let's now work on the update function. Remember, the update function is called by Unity for every frame of our application. The first thing we'll do in this function is check if download is complete. If download is complete, there's nothing for us to do in this function, so we return the puzzle has already been solved. However, if download is not complete, let's check if we're inside the trigger. Remember, we have this in-trigger boolean, which in a few moments time you'll see gets set to true in the on-trigger enter function and gets set to false on the on-trigger exit function. So this boolean always lets us know from within inside our update function whether the player is inside this switch's trigger. We might be in the trigger, but we might not be pressing the use button, so we will contact the input manager and call its get button function, passing in use as the button we wish to check the status of. If this returns true, it means that the use button is being held down. If that's the case, then we'll check we have a valid audio source, and if we have, and it isn't already playing, then we will start it playing. Then we'll calculate what our current download progress is. We do that by taking our download progress, each frame while we're holding down the use button inside the trigger, and adding onto it time.delta time. Download progress is just trying to count up to download time. But notice how I clamp this between 0 and the maximum time it can be, which is the download time, which by default of course was 10 seconds. Next up, we'll check that if download progress doesn't equal download time, then we haven't yet deactivated lockdown. So if that's the case, and we have a valid reference to our slider bar, then we will make sure that the slider bar is active by calling its GameObject's setActive function and passing in true. We'll also make sure that the slider's value is set. This will produce a value between 0 and 1. Our slider UI element is set to have a 0 to 1 range. Then we will return from the update function. If we're in the trigger and we're using the button and we haven't reached the download time yet, then we're really just making sure that the download slider bar is active and that its value is repeatedly updated to reflect the number of seconds the player has been holding down the use button without being interrupted. However, if download progress does equal download time, then that means we've been holding the button down long enough such that we have unlocked this puzzle. We have deactivated lockdown. So we will set the download complete boolean to true, and we'll also call that reset sound and UI function again, which you're going to see in a moment is going to reconfigure the UI elements and the audio source based on the fact that we are now in a downloaded state. What this basically means is that the slider bar is going to be hidden, the audio source is going to be stopped from playing, etc. So what we're going to do next is, because we've just deactivated lockdown, we're going to change the text that is on our UI. What used to say hold the use button to deactivate will now say successful deactivation. As we have deactivated lockdown, we will call the application manager's setGameState function, this time setting lockdown to false. And we will call our material controller's activate function passing in true, so the red texture now gets swapped for the blue texture. We will also activate the unlocked light, which is the blue light, and we will deactivate the locked light, which is the red light, and then we'll return from the function. Finally, at the very bottom of the function, outside the conditional, where it says if we're not inside the trigger, we will always reset download progress to 0 and reset the sound and UI elements. Remember, when we leave the trigger, that's essentially the same as releasing the use button. So whenever we are not in the trigger anymore, all of our progress needs to be snapped back to 0. So let's work on that reset sound and UI function. It's pretty simple. First of all, we'll check we have an audio source, and if the audio source is playing, then we'll stop it. Also, we have a valid reference to a slider bar. We will set its value to the current download progress, which actually isn't really necessary, but we will also deactivate the game object, alright, by calling it setActive function and passing in false. We will reset the hint text back to hold use button to deactivate. So you can think of this function as being the function that is called when we're not inside the trigger, or if we were inside the trigger trying to deactivate lockdown but then we left the trigger, or release the use button. When that happens, the slider bar disappears, the text says use hold button to deactivate, and any sound that was playing is also stopped. So we know we have interrupted the lockdown deactivation procedure. Okay, so all that's left to do now is the on trigger enter and on trigger exit functions. So remember, the on trigger enter function will be called by Unity whenever another collider enters it. And inside the function, the first thing we do is we say, hey look, if we're already in the trigger, then whatever collider is being passed here, it's obviously not us. Or if download is already complete, then it doesn't matter. This trigger mechanism is no longer working because we don't need the trigger to do anything when lockdown is deactivated. But assuming that's not the case, we will say, if the other collider we've been passed does have the player tag, then it is the player that has entered the trigger. So let's set the in trigger boolean to true. And you can probably imagine what the on trigger exit function is going to do. It's going to say if download complete is already set to true, then just return. Otherwise, if the collider that is leaving this trigger is the player, then set in trigger to false. And that, my friends, is our lockdown trigger done. So let's now go back to the editor and hook up some of these references to the UI elements, the light game objects, and set up its material controller. So here I am back in the editor, and I'm going to select my computer screen on game object, and if you look at our lockdown trigger component in the inspector now, you can see we have a few game objects to assign here. So the first one we need to assign is the download bar, which is our slider element. So what we need to do is drag the slider game object and drop it in there. Next up, for the hint text, we also wish to drag over the hint text UI element from our canvas and drop that in there. And then we have game object references to the locked light and the unlocked light. So the locked light is of course the red spotlight, so let's drag that over. And the unlocked light is the blue spotlight, so let's drag that over. So next up we need to assign the material controller, starting off with the reference to the underlying material. And of course the material we wish this to manage is our computer screen material. So let's drill down into our materials folder and let's drag over the computer screen on material and drop it in the material slot of our material controller. If it isn't done so already, make sure you set the diffuse color to black, set emissive color to white, and we wish to assign this now as the emissive texture, the blue texture from our textures folder, which is this computer lockdown deactivated texture here. As you can see, I'm assigning that to the emissive texture slot. So when we press play, this material has this red emissive texture, but when this material controller is activated, once we've deactivated lockdown, that texture will be replaced with this blue emissive texture. The blue light will be turned on, and we've already seen in the lockdown script that when that happens, the slider bar on our screen will also disappear and the hint text will be changed. So let's go and see what we've got so far and see if any of this works. Okay, so there's our computer screen with the red light. And as you can see, as I hold it down, the bar goes up. And if I let go, it snaps back to 0 again. Or if I walk out of the collider, it should probably do the same thing. There you go. Okay, so let's hold it down for real now and see if it changes to the blue texture and also the spotlight changes to the blue spotlight as well. Perfect. Let's now work on the sound. So on our computer screen game object, I want to add a component of type audio source. I'm going to assign this to the scene audio mixer group. I'm going to set the volume down to something quite low. It's just a computer, so it's not going to make a really loud sound. So something like 1.4 maybe. Sorry, I meant 0.14. We wish spatial blend be all the way up at 1. This needs to be a 3D sound. We want to turn off play on awake, but we do wish to tick looping because we're going to assign a looping sound here. So what sound are we going to assign? Well, let's see what we've got in our sounds folder. So selecting the sounds folder and drilling down into the scene sounds subfolder, we should have, there it is, it's a sound called computer download. Let's force this to mono and set compression to PCM and click apply. Let's listen to what it sounds like. That reminds me of my 56k modem days. Okay, so let's now go back, select our computer screen on game object, and drag and drop the computer download audio clip into the audio clip member of its audio source. And then let's click play and see if this happens. And you can see when I let go of it again, the sound stops and everything resets on the UI canvas, so everything's working perfectly. There you go, and it also automatically stops when we deactivate lockdown. So I think the only thing I'll change there to make our game a little more tense is I'm going to change the download time from 10 seconds to 15 seconds. Let's see what that's like. So that, you know, you can hear all of the zombies outside the computer room. You're hoping they don't come in and get you. And that 15 seconds is going to drag like a bitch. Oh yeah. There you go. I think that's the speed I had in the original Creeper, and also the speed I used for the computer download in Dead Earth Prototype. Okay, so what we need to do now is hook this up with our power generator. So our power generator turns the computer system on and off. So let's configure this thing now so that it looks as it should at application startup. So I'm going to turn off my computer screen on game object, and I'm going to turn on my computer screen off game object. Then I'm going to go over and select my power generator, and in particular the switch trigger of that power generator. And we need to add some more elements to the object activators and the object deactivators list. So I'm going to add one more element to the object activators list, and I'm going to drag in there my computer screen on game object into the last element there. So when this power generator turns on, our computer screen on game object will be activated. Then I'm going to add another element to the end of the object deactivators list. And this time, when the object is deactivated, I want that black computer screen off cube to be enabled instead. Okay. So let's go and have a look at the computer screen first. There it is, well and truly off. Now, let's activate the generator. And the computer screen has come on. Let's check if I turn the power generator off, the computer also goes off, which it does. Let's turn it back on again. Deactivate it. And then we'll turn off the power generator and see if the lockdown gets rebooted, so to speak.
Attention all personnel. This is an automated message being broadcast on the Syntac emergency broadcast channel.
Okay, so let's now go back to the power generator, turn it off, then turn it on again. I'm hoping it's going to come back on red again. Yep, as you can see, everything got reset. So what I'm going to do now is I'm just going to deactivate this. And when we go back to the elevator, it should no longer say that we need power or that we need to deactivate lockdown, because we've done those two things. There's only one more thing for us left to do, and that is to get the access code. So let's go and check that the keypad correctly tells us that we're missing the access code, and that is all. Hey, look at that. Access code required. Good stuff. Okay, with our computer system done, I'm going to leave it there for this lesson. When we come back in the next lesson, we're going to add the final puzzle to the game, which is going to be a really quick and easy and simple lesson, because the last couple have been pretty tough going, especially for me as the instructor. What we're going to do in the next lesson is we're going to create the access code. Now, the access code is going to be really easy. We've already got the script. It's going to use our generic switch for that. But what we are going to do is we're going to place some dead bodies around the level, and then we're going to create a prefab spawner so that the access code is randomly positioned on one of the dead bodies. So it's in a different position every time we play the game. So that makes it a little more interesting for us to play as the game developers, so that we don't always know where everything is. Thanks for listening, guys. I will see you next time. Bye bye now.